In this section, we're going to check the Linux password. We're going to see a little bit the anatomy of the Linux password, which touches upon the topic of cryptography. It's a whole field on its own. Therefore, we will not go into the deep details, but we will focus around the password hash that we have in Linux. And in later sections, we'll see how we can potentially crack this password. Okay, so if I get started by just cutting the shadow file, I'll do is a sudo because I need to be root to actually see it. So I put the password, and down here we will see our user, Kalia. Okay. Now we have a large sequence. We have obviously separated by colon as happens in these files, but between this colon after the username and before these columns, which have to do with timings around the password, for example, when it needs to be changed and so on. I want to focus in this section on the password hash only. So we see here a large sequence that doesn't really tell us much. Let's break it down into sections, and I promise you it will make sense. But before that, let's go and understand what do we mean when we say the word a hashed password. What does it mean that we are hashing a password? Now, I will put it quite simply. Hopefully it will be clear. Let's say we have our password 123 here. Okay. So what is the goal here is to create from that password, because obviously we don't want it exposed, we don't want it stored in plain text, to create something that can't be broken, can be reversed. Therefore, whoever is looking at that data doesn't see password 123, but sees something that doesn't really make sense. So if they try to put that in the password field, it will never accept it. So this is where the hash function and algorithms come in. Again, it's a whole topic on its own. Essentially, there are algorithms out there, so you definitely don't want and don't need to go and try and create your own hash algorithms. You can experiment a bit and just make some simple rules and say, I can try and make this, a large string of numbers and characters and create something that looks safe to you. But trust me, it can be broken. So the point of this is we have the password, and then we are using a hash algorithm. Obviously, Linux has that inside, so it does that. And then that creates as an output a long string of characters. Therefore, the point of this is to be one way. So the point of this is put the password, run it through the hash function, and then that is that. So it can't be reversed back. No one can now know or go back, at least that's the goal, to get the password just by trying to reverse engineer this. Now, what though can be done, for example, and it's one of the things we're gonna see in the next sections, we're gonna try to break our password, is if I do have lots of these hashes, okay, and if I have a lot of these passwords, like a password list, for example, what I could do is run them through an algorithm one by one, see what they produce, and then compare with the hash I have retrieved. So I can retrieve your hash. Let's say I'm a hacker and I steal your hash, I put it somewhere, and then I take a list of passwords that I have and I run it through the algorithm and I see, do I get exactly the same? If I do get exactly the same, then that means I know now what the password is. Because apart from the fact that it's one way, a good hashing function avoids collisions, which means anything that changes here, even a letter or something, will produce completely different output using the same hash algorithm. And obviously, if it's the same, then it will always produce, again, the same output. Therefore, if I find that, if I check the password 123 and I hash it, and it gives me that, and I have already that from stealing it from a database, let's say, I know that this user's password is password 123. Okay, so I hope that makes sense. The process is simple, is one way, and that's it regarding the hashing itself. Now let's go and see a little bit around the Linux specific structure that we saw. As a reminder, let me show you again here. You see we have, for example, here $$6, then again a number of characters, and then again a $, and then another large number of characters and some symbols. Okay, so this is the format we saw. What we saw was ID, which means which hashing algorithm is being used at the moment. Then we have the salt, which I'll explain in a second what it is, and here is the hashed password at the end. Okay, so the salt. Now, what do we call the salt? Now, obviously, having, for example, just password 123, okay, we create something that can be reversed, or someone can't understand from here by looking at it what the password is. The danger is that this password can very easily be in some sort of list. And as I said, we'll see in another section how we can kind of crack that. So an enhanced version of just having the password and running it through the hashing function is to actually have the password and adding here, let me just do it here and maybe increase a bit the size, add here a sequence, a randomized sequence of characters and numbers and so on. Okay, and you put those two together. So you try, for example, for each user this to be unique in your database. Let's say we put them together and then we run them through the algorithm. Remember, even if I change one single letter from this, that will change that output. So imagine if we add obviously something that's completely randomized, then it does enhance a lot the security point of view, which means that this needs to be known or needs to be discovered somehow, because otherwise, if you don't know this and you run through a list, you're never going to get this password 123, because the output will never be this one, because you will combine these two together. So this is the salt. This is what's called salted passwords, is when we have the password and we put together with a randomized string, and then we run them through the hash algorithm, and that gives some output. Okay, so that increases the security. It doesn't mean it can't be discovered. It just means it's obviously enhanced security compared to having the same password that can run around the world. Each hash can run around the world freely and be in a million different lists. Okay, now in terms of the ID, we have certain notation, certain numbers that Linux assigns. This is Linux specific, okay? One means MD5. Now, I'm not gonna obviously go through the details of the algorithms, but you can research those if you're, or get a course around cryptography, which will run through the details, but essentially just to know this, because we're gonna play with this. One means MD5, which is an older kind of hashing algorithm, does have vulnerabilities, therefore is not used frequently nowadays. 2A is Blowfish, and these two, 5 and 6, are the secure hashing algorithms, 256 and 512. Now, they differentiate themselves in terms of how many bits they use for the hashes. And obviously the number 6 is the kind of more secure one, if you like. So the number 6 that you see here, where is it? $6 is exactly this one. It tells us it's using a SHA-512. Another way of discovering this is you could have a look at, let's go and see where this is, at the Etsy login, I think, oops, I forgot to put cat here, sudo cat.defs. So if we go in here and we scroll up a bit, so this is where some definitions for the logged in user are. You can see here encrypt method, which is the one we saw before. This is the number 6 essentially. Okay, so you can see here the current configuration of this, of the encryption method. Right, so now with that information, I will show you. First of all, let me cut again so we can have it ready to see it, and maybe I will split the screen here horizontally. Okay, so here we have the hash password. Okay, in the next sections we're going to see how we can crack it, but for now I want to introduce you very briefly to a tool which is called OpenSSL. This is a cryptographic tool. Again, there is a lot to it, but we're going to see when it comes to the hashing, how we can generate exactly the same sequence here. Okay, so what we're going to do is we're going to say use OpenSSL, generate for me a password. So that's one of the modes that OpenSSL allows you to set to create hashed passwords. Then we put -6. This is exactly the number 6 that you have here, so the algorithm which we want to use. And then put a -salt to define what is the salt value. Remember what salt is the randomized, is this field here, is a randomized sequence. So we paste it, paste the selection, and then we say which is the password that we want. In this case, password 123. Okay, so we have the name OpenSSL, which is the cryptographic tool. Then we say we want to generate a hashed password. -6, which is the algorithm we want to use, the 512 one, and then -salt with the salt that we see here in the shadow file, and then what is the password we want to hash, essentially to create the hash of. And then we press enter, and we can see here, if you notice here, this sequence and this sequence are the same. And if I changed one simple thing, if I put instead of KN at the end of the salt, I put M, just a small change, you can see now you have something completely different. Therefore, you can understand the value of salt. Now, if you want to see more on SSL, again, do man OpenSSL, and it runs you through a cryptographic toolkit. And again, there is a lot to it. You can create keys as you need them. A lot of cryptographic operations. Among other things, you can generate, if I put here, hash, generation of hashed passwords. Okay, so this is the mode we used. Okay, so I will stop here before the section gets too long. I hope it was useful, and in the next section we're going to start seeing how in Kali Linux we can crack our own password and have a little bit of fun. See you in the next section.